DeHavilland Canada Engineering. Engineering in the 80s, it was a different world. As most people know, it was the DeHavilland Beaver and the DeHavilland Otter that really put the company on the map. They opened up the north for Canada, bringing supplies into lumber camps and mining operations. Without them, Canada wouldn't be the Canada that we know today and love. My involvement with these aircraft as an engineer was primarily in testing the turbine powered variants in order to validate DPS run charts and data that was used for specifically engine tests. This is a picture of the Otter, owned by Bearskin Airlines and flown by Harvey Friesen and Carl Friesen, two friends of mine. Carl is no relation to Harvey, they just share the same last name. Harvey and I used to fly together with Northwestern Ontario Air Search and Rescue. Getting back to maintenance, we did a lot of upgrades on the old Turbo Beaver with the Dash 20 engine, and also the Twin Otter with the Dash 20 engines, the 100 series. We did a lot of custom build specs in order to make that engine more reliable. Here you see a Viking Air conversion Turbo Otter with a PT6A 135 engine. That's a 750 horsepower engine, flat rated to 600 horsepower in the Otter. On the heels of the Otter came the Twin Otter, the first turbine engine aircraft produced by DeHavilland Canada. It was a versatile 19-passenger, small airline type aircraft that took DeHavilland into a completely new direction. Here I am island hopping in Royal Tongan Airlines Twin Otter aircraft back in the day. We helped the Tongans implement and operate their new fleet of Twin Otter aircraft. I taught them how to maintain and operate their engines. Tongan Airlines used the PT6A27 engines upgraded to Dash 28 specs. That meant that they flew the engines or operated the engines to a tighter T5 ITT limit of 1680 degrees Rankine on the test cell as opposed to 1700 degrees Rankine for the Dash 27 engines. By use of coatings in the hot sections, they were able to achieve the same power ratings at cooler temperatures. This really helped them with their hot, humid temperatures in the down in the tropics in the South Pacific. This is a 100 series Twin Otter with the PT6A-20 engines that I mentioned before. These engines had an old style hot section assembly that was sealed up with abradable cord seals, which was really a problem that we worked on in order to make the seals more reliable by using metal jacket cord seals that they used in Rolls-Royce type engines. That helped the longevity and reliability of the hot sections. In the 70s, they introduced the Dash 7 aircraft. This was a STOL aircraft of 50 passengers and 4 turbine engines. Pratt & Whitney PT6 A50 turboprops. My first job at DeHavilland Aircraft Engineering was to redesign the engine installation for the Dash 7 for the new Dash 7 200 series. It was a stretch Dash 7 aircraft that would use the new prototype PT6A 56 engines, which basically combined the A50 gearbox of the A50 engine of the previous Dash 7 with a new 65 four-stage axial compressor of the PT6A65 engine. The extra horsepower would be required to stretch the aircraft from 50 to 75 passenger seats. This turned out to be a complicated project because if you look at the picture, you'll notice there's a rear shelf and then a nacelle that supports a rear engine mount, which is on the bottom of the accessory gear case attached to the back of the axial compressor. And then there's a horse collar up front that establishes the front mounting plane ahead of the compressor. So with a longer four-stage axial compressor, space became a problem. There wasn't enough room to push the engine back on that rear shelf without it colliding with the structure just ahead of the wing spar, the forward wing spar. So we ended up doing a lot of work in order to fit the engine in properly. And still we had to move the engine slightly forward, which changed the center of gravity of the engine in the wing, which was a big program. In the end, they decided not to go ahead with the airplane, and we rolled up our drawings and submitted them to archives, sadly. Following the Dash 7, the timeline takes us to the Dash 8. What a marvelous aircraft. It was a fleet leader. People loved it. It was a market leader. Basically stole the market. Basically, it created a market that never existed before. With the advent of the Dash 7, de Havilland Aircraft started to realize that many of the operators that purchased the Dash 7 really weren't using it as a STOL type airplane that the Dash 7 was designed to do. And they didn't really need to pay the higher penalty of more drag associated to a high lift wing. They were mostly using the Dash 7 as a commuter type aircraft. And so they didn't need to have the STOL capability and four engines of the Dash 7. Of course, engine development was developing leaps and bounds at the time. De Havilland Aircraft Canada, in conjunction with Pratt & Whitney Canada, was developing the new PW100 series engine, which would be the future for the Dash 8, with a PW120 variant that was able to produce 2,000 shaft horsepower. So they no longer needed to use four engines and could get away with just two, minimizing complexity and drag and greatly increasing aircraft efficiency. With a new streamlined wing, fuel burn was much less than with the Dash 7 aircraft, and it quickly became the new greatest thing. Everybody wanted one, and therein lied the problem: production. De Havilland Aircraft was never used to having the order books full to produce so many aircraft so quickly. It was overwhelming. The factory was stressed. De Havilland Downsview in Toronto was a different kind of aircraft factory in the sense that back in those years, every single part, other than, standard hardware, nuts and bolts, and off-the-shelf items like instruments and engines, etc. But basically every part, every bracket, every wing, the wing section, the fuselage, the parts, the rate items that went into the plane, everything was jigged and fixtured and manufactured on site, including composites, wiring, all small items, small brackets. Everything was made under one roof in that factory. It employed about 5,500 people at that time in Toronto. And it was, in a way, unheard of in the aircraft industry. As the aircraft industry progressed, there was a new terminology called the rate item build, which was basically building components more efficiently at specific factories that would all come together at final assembly, and the aircraft company would do the final assembly and put it all together. This wasn't the case at DeHavilland Aircraft in those years in Toronto. The rate item builds were basically designed to fit into a standard shipping container. This way, parts could be made by low-cost labor centers in different countries around the world and shipped to the final assembly facility. Unlike the Havilland, that made all the components basically from comparatively expensive Canadian labor. The other problem they were having was the design system was antiquated, mostly done on paper. I worked propulsion design on the oil cooler installation, the bypass doors, inertial separators, and also the APU installation. A big problem they were having was the fact that there were so many different customers that were opting for Dash 8 airplanes that every customer, every airline wanted it a different flavor and slightly configured differently in terms of the interior and where the lavatory was and where the coffee station was. And everybody wanted a different thing. And the factory was very stressed out in terms of manufacturing and methods on how to control so many what they called customer requests, changes to the design that was all of a sudden warranted by so many different options and so many different customers. The other problem is the workforce was kind of used to building one thing. So you had the problem where guys on the line didn't understand the drawings and the changes and the amendments that were required. So when they were building airplanes, sometimes they were just going to the airplane that was already ahead and finished and sticking their head in the panel or in the interior and looking to see how it was made and just making it the same on the aircraft that they were now building. So that became a real problem in terms of reworks that needed to be done when those problems were spotted. You know, that the aircraft wasn't built properly or correctly. So wow, there was lots of rework, lots of overtime, lots of overruns in production, and lots of cost associated to it. That set the stage for DeHavilland Aircraft to look south, to look at what Boeing was doing in terms of manufacturing to speed up production, which led to talks and the eventual takeover of DeHavilland Aircraft, the government corporation, taken over by Boeing Aircraft Company for that grand total of $55 million and a defunct factory that needed an environmental control system for another $50 million, which included other factory upgrades as part of Manufacturing Action Plan 87. I've included a lot of the slides on this presentation talking about the Boeing Canada DeHavilland Division merger with a lot of extra detail if you're interested. Okay, well that pretty well wraps it up for today. If there's enough interest, I'll do a follow-on video talking about how things went with Boeing Canada at the Havilland Division. Okay, thanks for watching. And one more thing, I included some excellent videos for your enjoyment, watching the DeHavilland seaplanes flying out of Victoria, British Columbia. So stay tuned for that. There he is. Oh, he's on the ailerons a bit. Very nice. Sinking. Yeah, he's on step. It's a DeHavilland. Looks like a beaver. Radial engine. Now he's sinking into the lake, or into the sea, I should say. Yeah, it could be an otter with a radial engine. Beautiful. Or it could be a beaver. Let's wait till it gets closer. Do this for Glenn. He loves these videos. Oh wow, beautiful. Yellow and white. Those colors. They'll pass right by in front of us. We're at the lighthouse on the point in Victoria, British Columbia. Super. We're going to take the water taxi back. There you go, eh? There he comes. Action video. It's a beaver. It's a smaller one, dear, the beaver. Beautiful Victoria. There's old the otter, turbo otter. Oh, one's just touching down. One's gonna love these videos. Then he's gonna want to come to BC. Now that Mom's gone, he can come visit.
Another one coming.
The water taxi. It's a twin otter. Where's this one going? He's going back home, Joe?
He forgot somebody.
Must have forgot somebody. There's my favorite, right? That's my favorite right there, the twin otter. Going back. Our little water taxi's like, ah, there's one landing. Oh. Where is it? I lost it. There it is. Morning rush hour. Morning rush hour, harbor.